Hey everyone. Okay, take a deep breath. I know it's late, you're stressed, and that COMP1638 Database Management Systems exam is looming huge tomorrow morning. Trust me, I have been exactly where you are right now, just staring at textbooks at midnight, totally overwhelmed. But seriously, don't panic. As your upperclassman and your expert tutor for tonight, I promise we're going to get through this together. Just think of this as your high-yield explainer crash course. We're going to lock in the exact definitions, the absolute easiest real-world examples, and those critical keywords you need to guarantee those points tomorrow.
All right, let's just dive right into our roadmap for tonight. I've broken the whole semester down into 5 really manageable sections. We're looking at core architecture, storage fundamentals, data recovery, security principles, and a final checklist. Just lower your cognitive load right now, follow this plan, and you're going to walk into that exam hall with total confidence.
First up, Section 1, Core Database Architecture. This is the foundation you absolutely need to know. Honestly, mastering this concept alone is going to guarantee you some super easy points right on the first page of the test. So, let's clear up the biggest source of confusion right out of the gate.
So people use the terms database and instance interchangeably all the time in the real world, right? But on the exam, that is a massive trap. Here is your simple, one-line definition to memorize. A database is the collection of physical operating system files sitting on a disk. An instance, however, is the active memory, specifically the System Global Area, or SGA, along with the background processes. They are two completely distinct parts of the Oracle architecture.
Now, to really make this stick, let's look at a super easy real-life example. Think of the database as the pantry in your house. It's the physical storage where all the raw ingredients, your data, just sit there on the shelves. The instance, on the other hand, is the active kitchen counter where you're actually cooking. The instance is the active memory and the processes working together to prepare the meal. And keep this in mind, multiple kitchens, or instances, can technically access that one main pantry. But a single instance? It can only ever open one database at a time.
Okay, grab your pen right now and write these exact keywords down, because this is exactly what your professor is hunting for. For the database, write physical OS files. For the instance, write SGA memory and Oracle processes. Literally, if you see a trick question trying to say an instance is stored on a disk, you know immediately that it's false. No way.
All right, let's move right along to Section 2, Data Storage Fundamentals, Tables and Table Spaces. We're shifting from those physical disks to how the database actually organizes all this information logically.
Let's start with the absolute basics, the table. Simply put, a table is a logical structure consisting of rows and columns containing related data. Honestly, just think of it like a basic Excel spreadsheet. Imagine you've got a spreadsheet tracking employee info, right? Each row is a different employee, and each column is a specific detail, like their name or their salary.
For the exam tomorrow, the essential keywords you absolutely must write down for tables are logical structure, rows and columns, and related information. And remember, at a bare minimum, an Oracle database has to have tables to store any kind of useful information.
Scaling up from that, we hit table spaces. Officially, a table space is a logical storage container that groups related logical database objects together. So, if a table is a single spreadsheet, think of the table space as a massive, heavy-duty filing cabinet. It holds folders full of those spreadsheets, making sure the accounting data is kept totally separate from the HR data.
Now, look at how this all maps out. See how the logical container, our filing cabinet, maps directly to the physical disk on the back end? The really cool part is that the database administrator just manages that logical container, and Oracle handles exactly how it maps down to the physical disk completely behind the scenes.
Your essential exam points for table spaces are these specific keywords. First, locally managed. That means the table space manages its own free space using something called bitmaps and extents. And please, don't forget the big file table space. Oracle 10G and later allow big file table spaces that can reach up to 128 terabytes. Seriously? Dropping that 128 terabyte figure on the exam? That's enough data to fill thousands of standard hard drives, and mentioning it is a fantastic way to show your professor you really know your stuff.
Moving right along, we are on to Section 3, Flashback and Data Recovery, or as I like to call it, undoing your mistakes. This is your absolute ultimate lifesaver tool. It's huge for the exam, and it'll save your skin in your future career when someone, and it will happen, inevitably deletes an important table by accident.
First up here, the recycle bin. This is simply a logical container that stores dropped objects in the exact same table space they were originally created in, and the easiest real-life example is exactly what you're picturing right now, the trash bin on your computer desktop. When you delete a file, it isn't completely wiped from the hard drive instantly, right? It just moves to the trash, just sitting there waiting to either be restored or permanently purged.
Now, what's really interesting here is the exact syntax. You literally need to memorize this code snippet for tomorrow. When a table is dropped, you use flashback drop functionality to yank it right back out of the recycle bin. The exact command you need to write on the test is flashback table name to before drop.
For this one, your essential keywords are logical container and same table space. Seriously, be super careful with trick questions on this. Dropped objects stay in their original table space. They don't go to some separate physical storage area. Oh, and if they ask what technology powers general flashback functionality, you write down undo table space.
Okay, let's shift our energy over to Section 4, Database Security Principles, locking it down. Protecting a company's data is totally non-negotiable in the real world, which means it is an absolutely guaranteed major topic on your exam tomorrow.
It all starts with the CIA triad. This represents the fundamental data security requirements: confidentiality, integrity, and availability. This right here is the absolute core of pretty much all security policies you will ever implement.
To visualize this, think of the CIA triad like a real-life bank vault. Confidentiality? That's the thick steel door. Only authorized people can see what's inside, keeping your secrets actually secret. Integrity means the vault guarantees nobody has snuck in and secretly swapped real money for counterfeit bills. Basically, the data hasn't been tampered with. And availability means the bank vault is actually operational and open when an authorized user needs to make a withdrawal. It doesn't do you any good if you can't get to your money, right? So, the absolutely crucial point here is memorizing these three exact words: confidentiality, integrity, and availability. If you see a question asking for the fundamental data security requirements, don't overthink it. Just write those three down immediately. Now, within security, we also have authentication. This is simply the process of verifying a database user's exact identity before they're allowed anywhere near the system.
Just think of authentication as the bouncer at a super exclusive club. Before you can even set foot inside the database, the bouncer demands to see your ID to prove you are exactly who you claim to be.
There are 3 specific ways you can prove your identity, and these are absolute, non-negotiable, must-know keywords for the exam. You authenticate through something you know, like a password, something you are, which is biometric data, like a fingerprint, or something you have, like a physical smart card or a security badge. Write those 3 categories down for sure.
Okay, Section 5. You are in the final stretch now. Let's look at the final exam checklist for backup, recovery, and some final tips. We just need to know how to save our progress, essentially.
For your final topic, backup and recovery is simply the strategy and procedures involved in protecting your database against data loss. Think of it exactly like hitting a save point in a video game right before a big boss fight. If things go totally wrong, you can reload and start again without losing hours of hard work. For this, your essential exam keywords are reconstruct database, prevent data loss, and 24/7 operations, which just means large databases have to be backed up while they're running continuously. All right, you are now armed with everything you need to completely crush this exam tomorrow. But I do want to leave you with a bit of a provocative question as you finally close your books tonight. Once you leave the classroom and you get hired in the real world, with hackers and hardware failures constantly threatening your servers, is your data ever truly safe? Get some sleep. Good luck tomorrow. You're going to do great.